Hello everybody, Fixing Foundations here with something new. I would like to present to you something that I call Mixture Master. This is a course that I am going to be offering for free on this channel that is going to combine visual storytelling with mathematics material. And in particular, I want to focus on word problems about mixtures. These can be very tricky in college algebra, so the first lesson is going to be a very basic tutorial regarding percentages. Now, Max Mixer was a young man looking for a job, and because he had no connections, he reached out to Uncle Bob. Uncle Bob was excited. He always wanted to teach. Max Mixer would soon learn how to make drinks on the beach. Now, here in blue, I have created a little word problem. It goes, Max applies for 10 jobs within the span of a week. 2 employers reach out to him and ask him for an interview. What percentage of jobs that Max applied for during that week invited him to an interview? Now, I've drawn a little visual representation of the jobs as well as the percentages associated with them, at least some of them. So, all the way at the right of the bar, imagine this kind of like the battery bar that shows up on your phone when you go to charge it. If it's 100%, it's full, and if it's at 0%, it's empty. And if it's at 50%, then it's half full. Now, the squares here, they may not be drawn in equal sizes perfectly, but they're supposed to be equal. So just imagine that each square is of equal size. Each one represents one of the jobs that Max applied for. So right here at the between 5 and 6, this would be the 50% mark, because jobs 1 through 5 represent 1/2 of the jobs that Max applied for, and then jobs 6 through 10 represent the other half. And what we want to find is the percentage that reached out to him for an interview. So in order to solve for a percentage, a lot of the times you want to put the smaller number over the larger number and use division. So I want to show you a mistake that you could make if you were to put the larger number over the smaller number. And this is kind of usually an instinct when it comes to division. So if you were to put 10 over 2, right, because 10 jobs and 2 of them reached out. So if you were to put 10 over 2, this would simplify to 5, right? And you might say, oh, well, it's 5%. 5% of the jobs reached out. But thinking about this, right? So 50% is the halfway mark. We would have 40% here. And then this here would be 30%. Then 10% would be all the way back here. 20% would be in the middle, right? So just write them all. 20% would be in the middle. 10% would be all the way back here. So if only 5% reached out, it would hit this halfway point here. And that would only be half of a job, which doesn't really make sense. So this is not the way we want to do it. We do not want to put 10 over 2 in this example. What we want to do is put the smaller number over the larger number. And that's going to give us a number less than 1. And that's okay. A lot of the times when you work with percentages, you actually want to get a decimal. You want to get something less than 1. So we're going to try that. We're going to try putting 2 over 10. And then if we were to convert that to a decimal, you could put it into your calculator. I'll do that right now. So you put 2 divided by 10, that's going to give you 0.2 or 0.2, as a lot of people like to show that. So you get 0.2, and then to convert this to a percentage, what you want to do is move the decimal place 2 points to the right. So I would do 1 point, and then I do a second point here. But there's no digit here where this second point is. So what you want to do is drop in a 0. So right here you could see we have 20 right here, and then we would use that to create 20%, right? Because we move the decimal point 2 places to the right, so it would really be over here now, and then it's 20%. So when we think about that, that does seem to make more sense, because 20%, that would fall around here on the bar, right? This would be 20% full. And that would mean 2 of the jobs reached out to him. So the logic checks out. 20% is the correct answer here. Now, going on to our next example, Uncle Bob explained percentages so that Max could see how much milk he should add to a cup of tea. And I have another example here. A 240 milliliter cup of tea is comprised of 15% milk. How many milliliters of milk is in that cup of tea? And towards the right here, you can see that I've created a visual representation of what a lot of these percentages would look like. Again, it might not be drawn perfectly, but I think it's good enough to help you understand the concept. Now, if you look here, you could see that 60 milliliters would be 25%, 120 milliliters would be 50%, and then the total quantity, 240 milliliters, would be 100%. Now, if we want to get this to work, we need to think about what's going on here, right? One mistake you could make is you could try doing something similar to what we did before. You could try putting 240 over 15. This would give you, what would this give you? I'll put it into the calculator real quick. That would give you 16. So it give you 16%. And honestly, that is pretty close to the actual percentage we have here, but that's not going to actually work. What we need to do instead is we need to create 2 fractions, right? So thinking about it like this, right? Percentages, they're kind of like fractions, because when something is divided by itself in a fraction, it equals 1, right? So like, I'll write it over here, like 5 over 5. This is equal to a whole. Or a whole would be a better way of thinking about it, rather than 1. 240 here is the whole. And so if we were to put like 50 over 100, this would be half of the whole. This can be kind of a pretty confusing concept in mathematics, but hopefully it's something that you can get used to, right? So we have these proportions here. So if we put 15 over 100, that would give us 15%. So that makes sense. And we want to set it equal to, on the bottom here, we want to put the total number. So we want to have 240 here. And then on the top, we want to have X, because we want to find out how many milliliters of milk is in that cup of tea. So 240 is the whole. You can see that here. And we're trying to find a number smaller than it. We're trying to find out how 15 over 100 could relate to X over 240 in this way. And if we cross multiply, it should bring us closer to the answer. So if cross multiply, we get 100x. And that equals, I'll multiply 15 by 15 times 240. On the calculator, that's going to give us 3,600. Then what we do is we divide both sides by 100. And this is going to give you 36. And this isn't a percentage, right? Remember, we were working with the percentage here. This is actually a milliliter value. So it'd be 36 milliliters. And then if you see, right, 36 milliliters, it would kind of fall here, like somewhere around here. And to our diagram, that kind of makes sense. That's pretty close to 12.5%, which would be around 15%. So we have something here that actually checks out. So there would be 36 milliliters worth of milk in that cup, in that 240 milliliter cup that only contains 15% milk. And that's going to do it for this tutorial. Thank you very much for watching. I hope you learned something from it. If you are looking for online tutoring, you can feel free to send an email to the address you see on screen, which is fixingfoundationsfoundation@gmail.com. Thanks again very much for watching, and if you'd like to keep up with this series, please subscribe to my YouTube channel.